Welcome at Jongia Mixing Technology. Nice that you're watching our video. My name is Bart Brouwer and I work for Jongia as Area Sales Manager. Jongia offers a wide range of mixing and steering equipment which is based upon many years of experience. In this video, we want to explain to you the difference of working principle between the Rushton turbine and the concave turbine. The Rushton turbine is a well-known turbine which is applied for processes in which gas dispersing is required. The turbine has the shape of a disc with 6 radial vanes. These vanes create a strong radial flow. Such turbines are often used in combination with a sparging ring to distribute the gas evenly under the turbine. Due to the high shear generated by the shape and high RPM of the turbine, such turbine configurations are mostly located centrally in combination with baffles. A redevelopment of the Rushton turbine is the concave turbine. This turbine shows similarities with the Rushton turbine, with one specific difference: the elements are concave shaped. As you can see, we have prepared 2 similar tanks of 10 liters content. Each tank has 4 baffles and a sparger ring from which air will flow into the tanks while the turbines are running. We will run both turbines with the same amount of speed and the spargers will perform with the same amount of air. The airflow is being controlled by these 2 airflow meters. The amount of Newton centimeters between these turbines will tell us the difference in performance as far as power consumption is concerned. As you can see, each turbine is running at 550 RPM. So far, we have not yet let the sparger start, so the turbines are running in 100% liquid without any gas. What we can see is that there is a difference in Newton centimeters between the 2 turbines. That is quite interesting. What does this mean? It means that the difference in Newton centimeters between the Rushton and concave turbine is telling us that the Rushton turbine requires more power to do the job in comparison with the concave turbine. Without the air coming from the spargers, we see that the Rushton turbine is taking 29 Newton centimeters and the concave turbine is taking 16 Newton centimeters. Now we will start letting the spargers pump 3000 liters of air into the liquid. Meanwhile, we will keep the turbines running at 550 RPM. It's clearly visible that the concave turbine is creating a better air distribution in the tank. Certainly in the corners of the tank bottom, just below the turbine element. This is telling us that there is a difference in Newton centimeters between the Rushton and concave turbine. This tells us that also in this case, the Rushton turbine requires more power to do the job in comparison with the concave turbine. Now we will increase the airflow up to 6000 liters. You can clearly see that the concave turbine hardly has any difference in Newton centimeters compared to the Rushton turbine. Also, the concave turbine is much more stable with variation of airflow and the power consumption is constant regardless the airflow. In other words, the concave turbine can disperse much more gas at the same power consumption compared to the Rushton turbine. That is another quite interesting aspect. Also, there is still a difference in distributing the flow over the bottom of the tank. That has not changed either. What makes the difference between these 2 turbines? The Rushton turbine is shaping the flow just behind the turbine vanes in a concave shape. The concave shaped turbine is already having such a shape. Therefore, the flow is much better distributed in the tank and is also more stable. We could say that the concave turbine is benefiting more of the physical process due to the shape of the concave vanes. Now the question is, when we need to advise one of these two turbines to you, which one shall we advise? That's a good question which we certainly want to discuss with you. If you are interested in Jongia mixing technology, please contact us at jongia.com or give us a call. We are always happy to answer your questions about mixing and blending with Jongia Rushton turbines or concave turbines. Thank you for watching.